Hello, good morning, and welcome to Chapter 2.8. We are almost done with our trek through Chapter 2. This is the last section that we need to work on here. And I realized that I didn't open up the thing that I needed to open up. So let's open that up real quick. Sorry about this. I could just start the video over, but hey, that's too much. There we go. Okay. So we're rewriting equations and formulas today. The key thing, your learning target for the day, which we need to be able to do, is to solve for a specific variable in a formula. Now, a formula, you have seen these in the past. Maybe you just don't remember the word. But a formula is an equation that it's a preset relationship, right? Like area, right? You may remember that you had this formula for the area of a triangle, right? That would show you the area inside a triangle, 1/2 base times height, where your base was this and your height is that right there. This will tell you the area on the inside, right? You might have a equals pi r squared, and that was the area of a circle, where that was r, and the area gave you the stuff in between, how much space it took, right? These over here, right, are formulas. And today what we're going to do is take formulas, things with many variables, in fact, maybe without a number at all, and we're going to solve for the variable. So let's do our first example here, and our first example is going to be ax plus b equals c. And what we need to do here is solve for x. Now, what I want to point out about this, and when we're doing any kind of solving with lots of different variables inside, the key rule here is this, right? Treat variable terms like numbers, because that's what they are. A variable is just a number that we don't know yet. So can we subtract it? Yes, because we can subtract numbers, we can subtract variables, right? I want to draw a little corollary to this problem that you have right here, ax plus b equals c, because you've seen many things like it if you just look at this problem, right? I want to point out that this problem here and this problem here are the same problem, okay? It's just that we have, if we were to take this a value, right, we could say that the a value is 4, and we could say that the b value is 2, and we can say that the c value, right, is 10, okay? So this equation over here is the same as this equation over here. It's just got numbers for a, b, and c. And so what we're going to do is solve it the same way, because the a, the b, and the c are numbers, right? They're just numbers that we don't know yet. In fact, this is the general way of writing it, where I can write any number for these three things, 4, 2, and 12, or 5, -10, and 7, or whatever, right? We can make any equation just plugging in these numbers for a, b, and c. So we're gonna solve them the same way, right? On our equation on the left, we know that the first step would be to subtract 2. And I'm subtracting 2 over here because 2 minus 2 is 0, and so that goes away. And I have to do the same thing to the other side. Whenever I do an inverse operation to one side of the equation, I have to do it to the other. So I would have subtracted by 2 on both sides. So what does that mean I'm going to do over here? Well, here I subtracted by 2. So here, that b is the 2, right? So instead of subtracting by 2, I'm going to subtract by b. Now, this is where these ones are a little bit weird, because 10 minus 2 became 8, and that was very clear. We could combine these two things because they're the same term. They're both numbers. However, b minus b here becomes 0, so we're left with ax, which should make sense because that's 4x and ax, right? 4x and ax, same kind of thing. This is the part that's weird though, right? We can't do 10 minus 2 because we don't have numbers for these. But I know that I'm subtracting 10b from 2c. So over here, or excuse me, the c and b. So what I'm going to do over here is take c minus b. And that's just c minus b, right? I can't combine the terms, and so I'm just going to leave them with the operation that we did. We subtracted b from both sides, and so this is c minus b, right? Then we're going to divide by a, because over on this equation, we're going to divide by 4, and we end up getting 2. I'm dividing by this number multiplying the x. So over here, I'm going to divide by this number multiplying the x. A divided by a, those cancel, leaving the x. On the right-hand side, we have c minus b divided by a. I can't divide by the a in a meaningful way, so this is just c minus b divided by a. And this right here is our final answer, right? And what you might notice is that if you were to take these three numbers, the a, the b, and the c that we had earlier, and we were to just plug those in over here, right? Like let's take those numbers. X equals the c, which is 10, and the b, which is 2, divided by the a, which is 4. You'd get x equals 8 over 4, x equals 2. Notice that you get the same thing, right? In fact, we got it the same way. Look, we did 10 minus 2 first, and then we divided by 4, which is exactly what we did here. 10 minus 2 divided by 4, we got the 2. Solving for this particular variable allowed us to be able to do that in this manner, okay? So, we're solving for a variable. Variables act just like numbers. We do the same operations. It just looks a little bit funny because we're dealing with only variables. Let's do another example. 3x plus 2y equals 8. And we're going to solve for x, right? When I write for x, what that means is that I need to isolate the x. Isolate the x. Get the x by itself. So, that's my x term. That's what I'm trying to get by itself. So, I want to get rid of the 2y first. And so I'm going to use inverse operations to get rid of that. If this is a plus 2y, I'm going to subtract 2y. And if I do that to this side of the equation, I have to do it to this side of the equation. So 2y minus 2y becomes 0. This is 3x equals. And then on the right-hand side of the equation here, we have 8 minus 2y. Well, 8 and 2y are different terms. They can't be combined. So this is 8 minus 2y. Again, I'm just writing that substitution because I can't combine them. They're different terms. And then to get the x by itself, I'm going to divide by 3. And I'm going to divide this whole side by 3. Now, this is kind of strange. Notice that I'm dividing everything by 3, right? 8 divided by 3, 2 divided by 3. So on the left-hand side, those cancels and I get x. And then I have 8 divided by 3. And 8 divided by 3 is 8/3, right? I'm going to leave it as an improper fraction. Don't try to mess with it. Don't make it a decimal. Just leave it as an improper fraction. And then over here, I've got 2 divided by 3. Minus 2/3 y. That right there is my final answer because I have isolated x, right? I've gotten the x by itself on one side of the equation, and I have everything else on the other side of the equation. I have isolated x. Let's do one more example. We have a equals 1/2 bh. You might notice that this is that area of a triangle that we talked about earlier. And what we're going to do here is solve for h, meaning I'm going to try and get the h by itself, right? That's what I'm trying to get by itself. So I'm going to work on getting rid of the rest of the terms here on the right-hand side of the equation. And so again, what we need to notice is there's 2 variables, and that's okay. We're going to treat the variables like they're numbers. So the operation happening between all of these is multiplication. So how do I get rid of the fraction? If I'm multiplying, we learned that to get rid of a fraction, we multiply by the reciprocal. So I'm going to multiply this side by 2 over 1, and I'm going to multiply this side by 2 over 1, right? Recognizing that that's a over 1. So 2 times a makes 2a. 1 over 1, that's 1, right? So we just leave it. The 2's will cancel each other out. 1's cancel each other out. So we have BH on the right-hand side. Now, we're still working on getting the h by itself, right? So what operation is happening between the b and the h? That would be multiplication. So we're going to now divide by b, because we're trying to get the h by itself, right? Trying to get that guy by itself. So we're going to divide by b, because b divided by b cancels itself out. Just like 2 divided by 2 cancels itself out, b divided by b cancels itself out. If I divided the right-hand side by b, I have to divide the left-hand side by b. We get h equals 2a over b. And that is my final answer for that problem. I want to do one more quick example. This is one that's similar to something that you're going to see on your homework tonight. And it's just a little bit tricky. So I want to look at this equation right here. 5x equals 3x minus 1. And instead of having just x's there, what I'm going to say is, let's make ax equals bx minus 1. So notice that on the left-hand equation, what we're going to do to solve this is get the x's on the same side. Now watch how I write this. This is 5x minus 3x, right? Notice how I write this. This is 5 minus 3x, right? Which means that that's 2x. This right here, notice that that's kind of like showing our work for this particular step of the equation. The x's, since they're the same term, have no change going on. The 5 minus 3 is where we get 2. So this is 5 minus 3x. Now look at this one over here. We are going to do the same step that we did over there, right? Because this is the same equation, just numbers in for a and b. I'm going to subtract bx, and I'm going to subtract bx. So what does my next line look like? That cancels, and that's negative 1. But what happens over here? This was 5 minus 3. 5 minus 3. This is a minus b. A minus b. X. And now what's our last step? Well, over here, we divided by 2, and we got x equals negative 1/2. Now, we don't have a 2 right here. We have an a minus b. But we're still going to divide by that thing, right? Divide by a minus b. Divide by a minus b. So we get x, because these cancel. And we get x equals 1 over a minus b. Final solution. You got one just like that on your homework tonight. I thought I'd give you a little bit of a preview. Because this thing is tricky, right? This thing right there, to recognize to make that 5 minus 3, to make this a minus b is a bit tricky. But that's what we got for you today. There's 2 questions up on the board. That as soon as you are done with the video, do those 2 questions, get them checked off from Mr. Dilly, and start it on your assignment for today. Thank you.